So there are three types of logical operators we have. So one is and, or, not. Right. So basically, these logical operators are used to compare more than one condition at a time. More than one condition at a time. Right. So there are situations where, we have to compare at a time more than one condition. Let's suppose. So if there is a temperature is greater than 40 and humidity is greater than 25, then obviously the rainfall is going to happen. Else the probability is less. Likewise, we are going to compare the more than one particular condition at a time. In that particular situation, so we gonna use, there is an operator is called as a logical AND operator. So the basic phenomena is followed by the logical AND is that, let me talk here. Logical AND operator produces or take a decision positively positive if all the conditions are true. Hmm? If any one of the conditions become false, then overall result is also false. Clear? So comes to our operator, it produces true as an output. Either of the condition become true. Then overall result become true. If all the conditions become false, then only result become false. This is the phenomena is followed by the OR operator. Comes to the NOT operator. Not logical operator is behave like invert operator. Means true make it as false and vice versa. Yeah. Yeah. Right. So let us take our appropriate examples here. Like what exactly AND operator will do, what OR operator will do, and what NOT operator will do. Demo about logical AND operator. Let us suppose you take one example. Write a Python program. Write a Python program. Write a Python program to validate Gmail credentials are provided properly or not. See, what is the behavior of the basic Gmail credentials or bank credentials basically? If uh, if uh, if both mail and password are equal to registration time mail and registration time password, so that successfully logged in. Else, else, else wrong credentials given. Yeah. So if we look at now, I'll be writing now. For suppose registration time email, I will be taking a for instance registration time mail. I'll be take it as 1 second. Just hold on. Yeah. 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 So Venkat underscore Naik @gmail.com. This is the mail ID I'll be taking at the time of registration, which means what? For the first time, whenever you create a mail ID, you might have created like this, right? You might have created like this, right? Okay. And the registration time password, generally, we supposed to connect with a database and then we have to validate it. Yes or no? And let's suppose here I'll be taking the password as HYD123 and login time username password, login time email is equal to same. You can take Venkat underscore Naik @gmail.com. Login time password will be HYD isn't it? 123 or else 123. Now, what is the logic we supposed to write? What is the logic we supposed to write? If the registration time or login time email is equal to registration time email. If it is equal, this is a condition. And registration time password is equal to login time password. If both the conditions are true, then I can able to log in successfully, which means what? Probably here login successful. Else, absolutely, it will be tell you that wrong credentials. Yes or no? This is the behavior of the application. For that, we are writing a logic. Let us execute. Yeah, login successful because login is successful because this particular user ID and this login time user ID both are same. and this particular password and this particular password. Generally, these two will be comes from the database. These two will be comes from the database. And these two will be while login you are going to enter. Yes or no? So obviously, here this condition become true and this condition is also becoming true. According to logical AND operator, both the conditions become true, then only this particular part will be get executed. Any one of them, if we give invalid, obviously the else part will be get executed. Let us see now. I'll be giving a password will be wrong. 1, 2, yeah, that's all. Now at this particular time, this particular registration time password is this. But the login time password is this. Obviously, this condition getting failed, absolutely this condition become true. Still, obviously now it will be go to this particular portion, because any one of the condition become false, obviously it will be go to the else part. Let us execute now. Wrong credentials will be given. Are you clear, everybody?
Could you repeat one more time, sir?
See, here is I am demonstrating the purpose of the logical AND operator. What is the need of logical AND operator? When to apply, why to apply? The main intention is, if we pass both user ID and password according to the registration time, then the login is successful. Otherwise, wrong credentials given. This is the real-time situation. We supposed to write the same logic. So here, what is the need of the logical AND operator? Both email and password has to be same. If they are same, then only the login is going to be successful. Otherwise, I'll be taking OTP also. Server OTP. Server will send one OTP, that 1569. You will be enter the login OTP, which is going to be a 1569. Now I'll be add one more logical AND operator. Server OTP is equal to login OTP. If three conditions are become, so that login is successful. Otherwise, wrong credentials. Let's suppose we'll take a 3 are correct. Now these three are the, now these two are the registration time email password, and this is the server side email password, which is sent by at the instantaneously. Now you have to enter this as a valid, this has to enter as a valid, and this also will enter as a valid. If these three conditions become true, then only the email is going to be make it and take a decision as a login successfully. Else, any one of the conditions become like, how many parameters you are taking? Three parameters you are. 2 per 3 is going to be how many comparisons you are going to be take? 8 comparisons are going to be taken. How exactly you take here? The truth table is that, the truth table is that, the truth table is that here. What is that? Email ID, password, OTP, decision. Sometimes there will be 3 might be given wrong. The decision is going to be a wrong credentials will be given, because 3 are becoming false, right? 0, 0, 0. Then this time also it is be giving a wrong credentials. Sorry, here it shouldn't be 0, 0, 1, which means only the OTP is going to be given, right? Then obviously the result is going to be a 0, which means wrong credentials. 0, 0, or else 1, 0, which means only password has given right. 0, 0, password and OTP has given correct, and obviously it will be a wrong credentials given. 0, or else you can take 1, 0, 0, right? And 1, 1, 0, and then 4, 5, 6, right? So So 6 means 0, 0, 1, 0, 0. Okay. 0, 1, 1, 1. Then 1, 0. Sorry, here it is not 1 second, just hold on. See, the condition is any one of the conditions become false, then obviously 1, 0, 0, 0, 1, 0, 1, 0, 1, 1, 0, 0, 1, 1, 1. This is 1. Only the one case where this particular case only become the AND operator will be produce the right take a decision. Rest of all the probabilities and permutations will be becoming a false, because this is the nature of the logical AND operator. Either all the conditions has to be true so that the result is going to become like this. If any one of them become false, then obviously result is going to be like this. So 2 to the power of 3, 8 possibilities we're supposed to have the permutations and combinations. Clear? So you can change anyways, like, let me take firstly email I'll be giving wrong. Firstly, email I'll be giving wrong. What I'll be doing, so here rather than underscore, I'll be giving dot. So obviously the wrong credentials will be given. Now the email is going to be given correct, and I'll be taking a password as wrong. Then again it will be the wrong credentials given. Now passwords will be correct, but OTP I'll be make it as wrong intentionally. So now again it will be wrong. When it is going to be true, all has to be correct. Now all are correct, therefore the login successful. Are you clear, everybody?
It's clear, sir. It's clear.
Let us take another example. You write a program now. What is my program is that? Write a Python program to validate if PAN and Aadhaar must submit for opening an account at a bank. If both are submitted, then I can say that, if both are submitted, I can say that you have eligible to open an account. If any one of them not submitted, you have to tell to the user that, you are not eligible according to the RBI policies. Can you quickly tell me? Can you quickly write a program, someone? So take a valid things like if the person will be submitted PAN card, I'll be taking it as a true. If the Aadhaar have been submitted, I'll be taking it as a true. Now what is the condition we're supposed to write? If PAN card and Aadhaar, absolutely, I can say that, what? Dear customer, you have fully eligible to open an account at our bank. This is the prompt is going to be given to the user. Else, print according to RBI policy, you are not eligible for open an account at our bank. Now you just see here, absolutely according to the current situation, these are the Boolean values I have assigned them. This is true, and true is always become true, right? Obviously this particular resultant value is going to be given to you. Else any one of them become the false, then obviously it will be go to the else part. Let us take a current situation, let us execute. Both are true, therefore it has been given, output as like this. Yes or no?
Yes, sir.
Yeah, yeah, yeah. So if you change and check once, okay. Yeah. So let us take if let us suppose this particular case is possible in metropolitan city, but if we go with remote villages, I think people might not have PAN card for everybody because they are illiterate. Probably they might be belonging to cultivation background. So here the situation is that if you make a rule that if both will be submitted, then only then if somebody might not submitted PAN card, then what happens? Now the account cannot be opened. Yes or no? Even this is going to be a true and this is going to be the false. Yes or no? And obviously what happens now? Obviously not possible. Both will be false, not possible. Yes or no? So I think everybody have understand that when to apply the logical AND operator. Sometimes there is another condition. Aadhaar is my permanent residence address. PAN card is an identity proof. It's not an address proof. Aadhaar will be sometimes an address proof, and sometimes my permanent address would be there on the Aadhaar, but I'm staying in Hyderabad, which is their other address. So here there is another address is required. What is that? Address proof is required. Then what else you will be able to submit? Probably if I'm a owner, if I'm a owner of the house, then I might be submit a electric bill. If electric bill have submitted and Aadhaar is submitted and this particular thing is submitted, then only you will be able to open an account. This is a three-factor uh, 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 checking, because nowadays people might come from other country. They might not have a right valid proofs. They might be ISI agents. They might be something they'll be manipulate. So any one of the address proof is mandatory. If at least if we submit three, then only I would be able to allow you to open an account. This kind of things might increases. That might be increases slowly. Yes or no? Whatever the photo is there in Aadhaar and image processing is also might be increases. And biometrics will be has to be successfully completed. There will be n number of factors of authentications and authorizations will be increases. Accordingly, you have to customize the program. Are you clear? See, I'm not telling you the buttified program or static program. The programs are keep on increases are customized according to the rules are going to be changed at a bank, at everywhere. Yes or no? Guys, are you understanding?
Sir, understood, sir.
Correct.
Sir, if under both condition is there, which one will execute first?
It will be take left to right, It will be, let's suppose here,
Okay.
you make the electrical bill as a R. Yeah, this is the case actually, and R, instead of electrical bill, somebody will submit the gas bill. So you have to take a gas bill. Here, here, gas bill submitted by one person, but electrical bill is not submitted. Correct. So now this particular case, these particular two case will be become true, but comparison of Aadhaar and electrical bill, Aadhaar have submitted, this is not submitted. And here it is submitted. But gas bill, no, at this moment gas bill is submitted, electrical bill is not submitted. Comparison of Aadhaar and electrical bill, obviously Aadhaar have submitted, bill not submitted, therefore this condition become true. Then if he comes to here, instead of this, gas bill submitted, electrical bill is not submitted. Therefore, this condition also true. Are you clear? This is how within the same condition, more than one particular condition is also going to be included by combination of logical and or.
Got it, sir.
Correct, correct, correct. So, yeah. So here, I hope you understand even or also. So let me take a or condition. Or. Logical or, what exactly it will be doing actually? So if all conditions has to be false, then it will be produce a false. Any one of them become true, then obviously it will become a true. So let us suppose we take one example that, if we fill certain forms, there will be a name, there will be a phone number, there will be email ID, but there will be alternate email ID and there will be alternate phone number also. But I'm expecting name has to be entered. Name has to be entered. Input. Enter your name. And phone number is essential. Phone number is also be entered. Enter your phone number. And email ID is also be going to be entered. Enter your valid email ID. And now here I'm expecting that alternate phone number might be there, might not be there. Let's suppose there will be a true. And alternate mail ID may be true, may be false. Yes or no? So let us take a condition now. What is the condition? Obviously, if name. So here, if you take conditions, like, it's not a Boolean, right? Obviously, the name and phone numbers are essential. Yes or no? So we cannot take the comparison operators among the phone number and email ID and as well as this one. So we can take, alternate mail ID and the alternate email ID is given or not. That's a comparison. Like, alternate email ID or alternate phone number. So either of them have given, so that obviously name and phone number will be given, so that you can say that, what, absolutely form is submitted successfully. Clear? Else missing data while submitting. Yeah. So if you look at now, it will be taking a name Venkat and phone number is 7799132754 and valid email is venkat@gmail.com. Okay. Now you see, form is submitted successfully. Form is submitted successfully. Why? Now here the alternate phone number has been given, but mail is not given. You just change accordingly. Now phone number is not submitted, mail ID is submitted. Yeah, same, same. Yeah, form is submitted successfully. Yes, sir. So here you're supposed to understand when it is going to become a false. If both are have not submitted, then there is a result is different. Let us execute again. missing data while submitting, because either mail is not submitted, either phone number is not submitted. Both are the alternate together. I hope this is the behavior of the logical OR operator. I hope you understand everybody, right, properly?
Yeah, understood, sir.
Correct, correct. Let us
Yes,
go with
sir.
logical OR let not operate. So let us suppose I'll take a simple example. Write a logic to simulate inverter at a home. Inverter at home. What is the logic it would be followed? Let's suppose electrical power is currently true. Then obviously inverter power is false. For example, you just consider. Now if electrical power is obviously true, right? Then obviously, you know what happens here? It will be printer status of electrical power, electrical and inverter power powers, which means that, you know what? Electrical power, comma, inverter power. Yes or no? Now, obviously, I'm expecting that when the electrical power is true, I'm expecting inverter power is a false, and obviously, and electrical power is going to be true. Obviously, when the power is there, electrical power, inverter should be in off mode. When the power is go off, then the inverter power need to be on. So what is the now else part? What exactly supposed to write? Else, else, absolutely here, what I'll do, else printer status of electrical and inverter power, comma, electrical power, comma, not inverter power. Yeah. Now if you look at now, for example, according to the current condition, electrical power is on, inverter power is false. For the first time, this particular situation would happen. So when the moment electrical power is off, automatically inverter power is going to be on. Let us see now what is the use of the not operator. I'm just demonstrating to you. Let us execute firstly. Now you see electrical power is true and inverter power is false, because current is there, inverter will be in off mode. Let us the power is off. What happens, you see? So now if for this particular case, the electrical power become false, but the inverter power become true. So here this not operators convert the status of the power to the next, to the other true to false and false to true. That's a one case where exactly a not operator will flip the situation. True condition to false condition to the true condition. Are you guys understanding, right? What exactly does not operator?
Got it, sir.
Yes, sir.
Great, great. So lastly, we have bitwise operators. So they are logical bitwise and bitwise or bitwise exclusive or and left shift and right shift, tilde operator, which is a two's complement operator. See, basically, bitwise operators are not going to use in a day-to-day life. They will be used in data encryption and decryption. Correct. Let us understand now. Let's take one by one. Yeah. I'll be taking, let's suppose, demo about bitwise operators. Like now, bank customer ID is equal to something I'll be giving 7799132. And the password will be given something called as a US 123. See, in the computer, there will be OSI model. Whenever you install the network drivers, there will be OSI model will be there in every electronic devices if it is connected to internet. There will be 7 layers basically. Computer science people might know application layer, presentation layer, session layer, transport layer, network layer, data link layer, and then physical layer. Physical layer. If you look at here, there is a layer is called as a presentation layer. Is a job is does by the bitwise data encryption and decryption of the purpose. The presentation layer purpose is data encryption and decryption in client and in the destination also. This is the destination computer, this is the client computer. Both the computers will have the OSI model, both the side. Here if it is encryption happen, here it is a decryption would happen. This is having a MAC address, this is also having a MAC address, network layer having a IP address, and the transport layer is having a port address. This is how you might have heard about all this while writing client server applications. So now ultimately I just wanted to tell you the use of the bitwise operators for masking of the data, which is does by the presentation layer in order to protect the data from these hackers or intruders. For that reason, while traveling the data, while transferring the data from the network, as usual data should not be go through that. The encrypted data has to be go through that. That is does the encryption by the bitwise AND, bitwise OR, bitwise exclusive, so on. Clear? Now, what I'm doing here, using the ASCII value, the actual customer ID and password is converted by the presentation layer in another form. That, encrypted customer ID, encrypted customer ID, which is going to be a 65. And encrypted password at a client only, 15. If you perform the encrypted customer ID and bitwise and encrypted password, I think you will be getting a result as 1 through the network. You see the output? I have given in my computer my bank credentials like customer ID is this and password is this. Presentation layer will be converted these two into an ASCII characters, and then eventually that does this particular specific operation through the network. It will be go only 1. So hacker or intruder highly difficult to understand what is the meaning of 1. That is the main purpose of the bitwise AND operator. How does it happen? You take bitwise operators will work at a binary bit level. Now I'm just taking 65 binary equivalent value will be 1 0 0 0 0 1, and the 15 will be 0 0 1 1 1 1 1. This is the equivalent value. Now if we perform the bitwise AND operation, this operation, what happens here? true and true will become true, and true and false will become a 0 and 0 and 0 0 0 0. This is the encrypted value will be going through the network. This is the network data. This is the reason it is given as a 1. This is how the operation will be done at a binary level, not at a byte level. I hope everybody is clear about it, right? In a similar way, some applications, encrypted applications, can perform elect customer ID, CID, bitwise OR operator now, password, elect encrypted password. Now it will be give you 79 as an answer. You see, this is the value which is in binary form will be going through the network if you perform the bitwise OR operator. How it is performing? Similar, same, it will be performing at a bit level, at a binary bit level, which is going to be a 10001 001111. If you now perform the bitwise OR operator, then true plus true will become 1, 2 plus 1 will become 1, 1, 1, 0, 0, 1. So this 1 will be having a binary decimal equivalent value is called as a 64. 32, 16, this is going to be a 8. This is going to be a 4. This is going to be a 2. This is going to be a 1. 64 plus 8 plus 4 plus 2 plus 1 is going to be a 79 equivalent value. This particular binary equivalent value will be going through the network data. This is how the data will be completely encrypted format. Absolutely, that would be useful for you. I hope everyone is clear. In a similar way, now some applications might use bitwise exclusive operation, CID. There will be a cap operator called as a bitwise exclusive OR and password. Now the phenomena is followed by this particular bitwise exclusive OR is that if inputs are dissimilar, produces true as an output, else false as an output. This is the phenomena is followed. This the behavior of this particular bitwise exclusive is electrical switch behavior. Electrical switch. See, the electrical switch is positive and negative will be go, then bulb is going to be enabled. Otherwise, the bulb is not going to be enabled. That's how bitwise operator is going to be bitwise exclusive operator is going to behave. Now, if I perform the operation between the customer ID and password, the output is going to be thrown to you as a 78. You see now, this is a 78 is an output. How did you happen? How did you get that? You take the same result accordingly. Now, 10001 001111. But here I am performing. What exactly I am performing? I am performing the exclusive operator. What exactly? If the inputs are dissimilar, means 1 and 1 are similar, therefore the output is 0. 0 and 1 are dissimilar, output is 1, 1, 1. Inputs are same, 0, 0. Inputs are dissimilar, 1. So 64 plus 8 plus 4 plus 2 is equivalent to the 78. This particular binary value will be the network value, which is an encrypted data. If it does the operation called as exclusive OR operation by following this phenomena. I hope you everyone understand. Let us go with the next type of an operator, bitwise operator such as left shift operator. This operator will be alternate operator to the multiplication operator when it is followed binary weightage. Let us see now. I'll be taking x value as 2. If we perform the value, if we perform the x into 2, it will be produced the output as, you know what, 4. Even if you perform the left shift value, x left shift one time, it gives the same result. You see the output? It's a result, and this is a result. See, according to the scientific observation, whenever there is a possibility of performing a particular number by the multiplication operator, if there is a arithmetic logic unit will taking a more headache, more burden. Rather than that, why don't you perform the left shift one time? That will be a simpler job for the arithmetic logic unit, scientifically proved. So if you want this kind of a necessity, better you go with this. Same result will be produced. And performing the multiplication with a 4, left shift 2 times will also be same result. Performing the multiplied with 8 and at left shift 3 times is also be performed the same result. And multiplied with 16 and left shift 4 times is also the same result. How it happens, like that's a point here. Let's take one example. At a binary level, 2. What is the binary equivalent value? 1, 0. This is the binary equivalent value. So whenever if you perform the left shift, one time the left shift value will be shifted. Now 1 will come here and 0 will be comes and sit into this particular place. This is going to be 0. After left shifting, this particular place is vacant. According to the uh, electronic assumption, vacant place is going to be pushed with a 0. Now, if you combine the 1, 0, 0 equivalent value is called as a 4. This was 2. Now, if you perform the left shift 2 times, again this particular value will be go to the left 1, 0, 0, and 0 will be pushed. Then it is going to become a 8. If we perform thrice, this will go again 1, 0, 0, 0, 0. Absolutely, it is going to be a 16. Again, if we perform the left shift 1, 0, 0, 0, 0, 0, then it is going to be 32. So I can say whenever the multiplication is want to perform, which is followed in a binary weightage format, 2, 4, 8, 16, 32, 64, 128, 256, 512, 124, then straight away you can replace this multiplication by the left shift operator because they produce the same result. I hope everyone understand that how a multiplication operator alternate is a left shift operator. That would only applied, at a real time to achieve certain electronic level kind of. When the device size will be, where is nanotechnology devices, which means then there would be, very less in size. Very, 10 to the power of -9 is going to be the size of those devices. We cannot take the arithmetic operators. Rather than that, shifting the operators will be the better approach for them. Is that clear, everyone?
Yes, sir.
Clear, sir.
Great. So the next operator is that bitwise right shift operator, which is this operator. This operator is an alternate operator to the division operator. Wherever there is a division operator is required, when it follows the performing a division in a binary weightage level, that means the given number will be the given number is going to be the 20. If you perform this particular division n divided by 2, it gives the value called as a 10. Even though if you perform the division n right shift one time, will also be giving the same result. You see. Then we can able to apply this right shift operator rather than the division operator. How exactly it is happening? Let me take an example here. So this is a binary value and 20 is a decimal value. An equivalent value will be 16. 16. Just hold on. 20 binary equivalent value will be 1, 0, 1, 0, 0. Now, if we perform the right shift once, which means this particular bit is called as a LSB bit, least significant bit. And this particular bit is called as a MSB, most significant bit. According to the electronic assumption, whenever you performing a right shift once, this particular least significant bit will be discarded, whatever it can be 0 or 1. Then rest of the bits will be shifted to the right hand side, which means what? Now this 0 will becomes here. This 1 will becomes here. This 0 will becomes here. And this 1 will becomes here. Now earlier this actual value was 20. The actual value was 20. After the right shift once, the 20 has become 10. Because 1010 equivalent to 10, right? Yeah. Once if we perform the right shift, the value has become half. Again, if we perform the 2 times this right shift, what happens? This particular 0 will be go off. The remaining is going to become what? 101, which is going to be equivalent to the 5 in binary. Again, if we perform the right shift once, this 1 will go off, 10 will be left over. This is going to become a 2. And if we perform again the right shift, this 0 will go off, 1 will be left over, which is going to be the 1. Again, if we perform the right shift, this will be go off, 0 will be left over. It's going to be 0. This is how, if you want to perform the division operation by 2, 4, 8, 16, 32 like that, rather than taking the division operation is a burden to the arithmetic logic unit to perform the operation arithmetically, rather than that you apply the right shift operator once, twice, thrice like that, so that the equivalent result you are going to get. This is a scientific observation towards the bitwise right shift operator concept. Clear? The last one we have that tilde operator, complement operator, which is tilde operator, right? So exactly I'm taking there is a v is equal to 10. So if you perform the tilde operator to the v, it would be give you minus 11 as an answer. Why like that? How it has been performed? Let me show you. It performed complement operation. 10 is what? It's a decimal value. If you convert into binary, 10, 10 will be the equivalent binary value. If we add a 1 to this at a least significant bit, so that it will be a 2's complement operation. 0 plus 1 is 1, 1, 0, 1. This 10101011 will be an equivalent to the decimal value called as a 11. And according to the electronic assumption, if the most significant bit will be the 1, it will be considered as a negative value. If the most significant value will be the 0, it will be a positive value. So according to that, the output computer is given as a minus 11 whenever you perform the tilde operation, which is a 2's complement operation for the given value. right? So these are all operators are electronically used. Probably being a software developer, you might not be doing all this, but it's your responsibility to understand what exactly these operators are, what that does actually. So I think with this, all these 7 types of operators I have completed according to my knowledge. So let us cross verify that, what operators we had. Yeah, so we have totally 7 types of operators: arithmetic operators, relational operators, logical operators, assignment, membership, identity, and bitwise operators. Right. So tomorrow I think I'll be start with I think tomorrow there is no class. I think Monday we have, that is control statements. We had up to looping statement for and while I spoke. Then I'll be start with a nested and loops, and then special statements will be seen in the Monday's class. Do you have any questions, guys?
No, sir.
Nested loop also, right?
Yes, sir. Nested loops not yet discussed.
Okay, got it, sir.
Yes, yes, yes.
So I just wanted to check on the notes thing. So you had shared a link, right, day before yesterday, chapter 1 something.
Yes,
So I
yes.
can see only chapter 1. So is it something related to my access or?
See, I hope you are seeing my screen, right, Kevin?
Yes, I see it now.
Yeah, so like there are many chapters, totally 13 chapters we have according to the syllabus.
Okay.
I think you have a syllabus, right?
Yeah, I have it. So right now
Ah.
I can see only chapter 1 from that link. I am unable to see the others. So
No,
is
no,
that
no, not
something
it.
you?
No, 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 I haven't uploaded for
Oh,
others.
okay, okay. Then fine. Yeah.
Yeah,
Okay.
so you are seeing now operators, fundamentals of
Correct.
Python, and control statements. All assignments and materials, everything is available. See, as
Okay.
classes are progressive, I'm organizing properly. If I at a time, if I upload, I think people would be confused, and ambiguities and a lot of unnecessarily doubts would ask. Therefore, as classes are progressively going on, I'm just uploading it. Yeah,
Okay. Yeah, then fine. Yeah.
great. Even video
Got it, sir.
recordings, everything will be provided by the LMS, right?
Correct, sir.
Great, great. Yeah. Thank you so much, guys. Bye bye. Take care. Bye.
Yeah. Thank you.
Thank you, sir.
Sir,
Advance happy birthday.